Hi folks, we're going to look at a few problems from the Unit 6 assignment, Part 2. Okay, so we're going to look at these factoring questions here. So in each case, we just want to factor. All right, so let's start with 1b here. So the first thing I notice is there's some numerical common factors. So each of these three coefficients has a factor of 3. And then I see that there's common factors of b. In fact, looks like there's a b squared that's common to all three. So let me start by factoring that out. So here I've got 3b squared. So let's see what we're left here when we factor out. So we divide -6 by 3. We got -2. b squared, we've taken that factor out. So I'm just left with 2a. Here, I'm going to be left with 9 divided by 3 is 3, and I've taken out 2 of the factors of b, so I'm just left with 1, so 3b, and then here plus 15 divided by 3 is 5, and I've taken out the factors of b squared, so we're at that. So this is actually a factorization. Okay, it doesn't look like there's much else I can do here. The only thing I'd say is that ideally we like our first term to be positive if possible. So what I'm going to do is I'm also going to factor out, and I could have done this in the first step, but I just want to show you how you can still do more factoring after you've done one round, is I'm going to factor out a -1 just so that my first expression here is going to be positive. Okay, so if I factor out a -1, so that's going to be a -3b squared. Okay, here I'm going to be left with positive 2a, here I'm going to be left with positive 3b, and here I'm going to be left with -5. Okay, so we see here that the only type of factoring that we used was common factoring, and sometimes that's just the case. So again, if possible, keep that first term positive. All right, so let's move on to 1d. So this one here, I hope when you look at 49d squared, you realize that that looks like it's kind of special. And 49d squared can be written as 7d all squared. In other words, it's a perfect square. And 1 is also a perfect square because it can be written as 1 squared. So if I can show that this middle term is twice the product of these two, and what is 2 times 7d times 1? That's indeed 14d. So this represents a perfect square. Okay, so by noticing that, I don't have to actually go through the process of figuring out the factorization. So this is just going to be, well, the first is going to be 7d, okay, and then plus the last, which is going to be 1, okay, and all this is squared. And if you want to check, just go backwards and remember the strategy for doing this. Square the first, so 7d squared is 49d squared. Square the last, 1 squared is 1, and then twice the product of first and last, so 7d times 1 is 7d times 2, 14d. All right, so let's move on to E here. So no common factors, so we're just going to have to factor the traditional method here. So I got to work with 12 and 21, which neither are prime. So let's start with, I'll start with 3 and 4 for my 12. Okay, so this represents the factors of 12, and let's do 3 and 7 for the 21. Okay, so here 3 times 3 is 9, and 28, there's no way that's going to get to a 4. And if I go the other way, 21 and 12, again, there's no way that that's going to add up to 4. Okay, so instead of 3 and 4, let me try 2 and 6, and here I'll stick with the 7 and 3. So sometimes you have to go through more than one round. So let's test this out. Here we've got 6 and 42. Well, that's not going to be helpful at all. And here I've got 14 and 18. That is going to work, okay? Because with 14 and 18, I can add that up to 4. Okay, so let's set this up. So remember, these represent the coefficients of x. So this is going to be 2x, and this is going to be 6x. Okay, and remember which one worked, the one that went across. So I'm going to have to multiply the 2x by 7. So that means the 2x represents the outside term. I'm going to have to multiply that by 7, and then the 6x has to be multiplied by 3. So that's going to be the inside terms. And all I have to do now is figure out these signs. So since it has to add up to positive 4, it's going to be the larger product that's going to be positive. So it's going to be positive 18 and then minus 14. All right, and there's my factorization again. If you want to check, 2x, 6x gives me 12x squared. Negative 14 plus 18 is 4, and then 3 times -7 is 21. Okay, so let's move on to this one here. There's an interesting one because I see 4 terms and it might look a little different than the ones we've solved, but when we have 4 terms, there were 2 factoring methods that we saw. Each involved grouping together some of the terms. Okay, and one way was to create a difference of squares, but I don't see how that would work because I've got this subtraction of 15 here, but 15 is not a perfect square. In fact, I don't have any perfect squares in here. So I don't think that's going to be the way to go. So what I'm going to try to do is our other method for grouping, which is to group together the first 2 terms and the last 2 terms and look for common factors in each. So let me start here, and I see that there's a common factor of 2, and there's also a common factor of w. So let me remove that common factor, so 2w, and let's see what we're left with. Well, here we're just left with z, and here plus, well, the w's gone, 6 divided by 2 is 3. Okay, so the only way this method works is if I can recreate this binomial in the second pair. So is there something I can factor out of negative 5z minus 15 to end up with z plus 3? And I see here that I can factor out not just a 5, but I'm going to factor out a negative 5. Because when I factor out a negative 5 from the first, I'm left with just the z. And here negative 15 divided by 5 is going to be positive 3. And so I've accomplished what I set out to accomplish. So that means this will work. So here I see a common factor of z plus 3. So that's the common factor that I remove. And what am I left with in the first expression when I remove the z plus 3? I'm left with 2w. And here, when I remove the factor of z plus 3, I'm just left with the minus 5. And there you have it, factored form. All right. So let's go down. The last one we're going to look at is for f. So here, I don't notice any numerical common factors because of that 13, but I do notice that they all have common factors of x. So x, so here I'm left with 6x squared minus 63, and then minus 13x. And here I notice, so I just have a quadratic trinomial, just not in the form that I expect to see it. So I'm just going to move things around so that's a little more familiar. So keep the squared term in front, but here I'll put the term with x next. So minus 13x and then minus 63. Okay. So now we have to try to factor this here. There's nothing else we can do in terms of common factors. So let's say for 6, I'll use 2 and 3. Okay, and for 63, well, that's just 7 times 9. So I'll try that, see if that works. And there's also 3 times 21. But this one looks like it's got more potential. So let's see what happens here. So 2 times 7 is 14. 3 times 9 is 27. And I actually think my first try is actually going to work. Okay, because 14 and 27, what's the difference between them? It's just 13. Okay, so I still have my factor of x in front. So let's set up our binomials. So I have 2x and 3x. And here I need the 2x to multiply 7. So 2x is going to multiply 7. And I need my 3x to multiply 9. Okay, and it has to add up to negative 13. So that means it's going to be my larger product, namely my 27, that's going to be negative, and then my smaller product is going to be the positive one. Okay, and again, let's just check 6x squared. Here we've got 14 minus 27 is negative 13, and negative 9 times 7 is negative 63. All right, so you'll notice here that the first step in solving these is really recognizing what's special about each individual one. So in this case here, there was a common factor, and that's it. Here we notice that it was actually set up as a perfect square. Okay, this one here, nothing special, we just had to factor it out. Here, the 4 terms, we knew we had to do some kind of grouping. Just which one. In this case here, there was nothing that indicated perfect squares, so we grouped the first 2 and the last 2. And this here, we factored out a common factor, and then we just rearranged the remaining trinomial so that it looked a little more familiar, so it was a little easier to factor it afterwards. Okay, that's it for these.